The life cycle of a battery is covered in 4 episodes and targets to analyze the strategic value chain of one of the products in the context of moving forward a low-carbon and more circular economy. In the second episode, we will see how the raw material is processed to become a lithium-ion cell first, and then a battery. How a cell is made. Step 1, slurry preparation. Step 2, coating and drying. Step 3, calendaring. Step 4, cutting electrodes. Step 5, cell assembly. Step 6, electrolyte filling. Step 1, slurry preparation. The dispersion of slurry constituents and their states are critical in design and development of mixing and coating processes for producing lithium-ion batteries. Performance of the lithium-ion battery depends on microstructure of the electrode. Uniform distribution of the agglomerated particles on the active material is crucial for establishing a conductive network around the active particles. Step 2, coating and drying. The coating adhesion strength of lithium-ion battery electrodes is a very important mechanical property. It affects the electrochemical lifetime of the cells and the electrochemical handling during cell manufacturing. Step 3, calendaring. Calendaring is the common compaction process for lithium-ion battery electrodes. It has a substantial impact on the pore structure, and therefore, the electrochemical performance of the cells. To optimize the pore structure, it is of decisive importance to be able to control the compaction process. Step 4, cutting electrodes. It's the laser process for cutting, annealing, structuring, and printing of battery materials. It has a great potential in order to minimize the fabrication costs and to increase the performance and lifetime of the cells. Step 5, cell assembly. The process is to build the electrode subassembly, in which the separator is sandwiched between the anode and the cathode. 2 basic electrode structures are used, depending on the type of cell. A stacked structure for prismatic cells, and a spiral wound structure for cylindrical cells. Prismatic cells are often used for high-capacity battery applications to optimize the use of space. In cylindrical cells, anode and cathode foils are cut into 2 long strips, which are wound on a cylindrical mandrel, with a separator keeping them apart. Cylindrical cells have only 2 electrode strips, which simplifies the construction considerably. Step 6, electrolyte filling. Filling a lithium-ion battery with electrolyte liquid is a core process in battery manufacturing. Incomplete filling negatively impacts electrochemical performance, cycle life, and safety of cells. Better understanding of this process will reduce costs while enabling high product quality. How a cell becomes a battery.
This is a cylindrical cell and this is a pouch. The cells are connected together in series in parallel in order to obtain the wanted result in terms of kilowatt-hour and output power. This is a BMS. The BMS is very important to equalize every single cell of a battery pack and to prevent potential dangers due to overheating, overfreezing, overcharge and overdischarge. Tacita is a green manufacturing and engineering company based in Italy that produces electric motorcycles for road and off-road riding and high-tech powertrains. We assemble the cells in our facility in Torino. Tacita Fabrica headquarters is powered by the solar trailer Tacita G-Station, which recharges the motorcycle battery packs as well.